Hello, dear aspirants. This is Dr. Sourav Sir's class. We are solving the CSIR NET 2024 June questions here. So, this question is about linear algebra, and the question is our multiple correct answer question. So, the question tells us that let our V does not equals to 0 be a finite dimensional vector space over R, and T from V to V be a linear operator. Suppose that the kernel of T equals to the image of T. So this is the key point of this question. That is, our kernel of T is equals to my image of T. Okay. So now which of the following statements are necessarily true? So as they have given R here, so this is my multiple correct question. So yeah. So as our kernel of T is equals to image of T, we know that from our rank nullity theorem that rank of T plus nullity of T is equals to my n here. So as our rank and kernel is equals to image T, so dimension of kernel T will be equals to my dimension of image T. That means what? That means my rank of T, no, that means my nullity of T is equals to rank of T. Yeah. So this we got from where? We know that from our rank nullity theorem. So from this thing we will get 2 of rank T is equals to my n. So our n is so as our rank of T will always be an will always belongs to natural numbers. That means our rank of T will always be a natural number. So our dimension of V will be even. Yeah, this is my true. This is my correct option. So our option A is true. Now we have to think for our option B, C and D. That our kernel, okay, so we again using the thing which is given in our question that our kernel of T is equals to my image of T. Let us pick an element K from the which is my belongs to kernel of T. As our kernel of T is equals to image of T, we can easily write that our K will be my some TV. As TV belongs to our image, so that can be look like that. So V belongs to my V, which is given vector space here. So as we know that K belongs to our kernel T, so we can easily write that our Tk will be 0. So now our K is equals to TV. We after using this thing, we will get this. Yeah. So now our T square of V is my 0, and and where our V is belongs to the given vector space V. So what can be done after that? So our T became a nilpotent matrix of order 2. So the eigen, as we know that the nilpotent all the eigenvalues of the nilpotent matrix are my 0. So the eigenvalues of T are zeros. So let me look uh, let me look after the options. So what are the options B and C tells us that the trace of t is 0. Yeah, that will also be true, because as our all the eigenvalues are my 0, so the trace of the matrix will also be 0, as our trace is the sum of all eigenvalues. So now the minimal polynomial of t cannot have two distinct roots. Yeah, that will also be true, because all the eigenvalues are my 0, and the roots of the minimal polynomials are my distinct eigenvalues. So as all the eigenvalues are 0, so they cannot have two distinct roots, and the minimal polynomial of t is equal to its characteristic polynomial. That may not be true. So that may not be true. So our option A, B, C is true for this question. So the correct answer of this question are my option A, B and C. Hope you understood, guys. Thank you.